Now let's examine the external and adjacent structures of the nose, which serve as the initial pathway for air entering into the respiratory system. The anatomy of the nose is designed to optimize the air that enters into the lungs, ensuring it's filtered, warmed, and humidified before reaching the lower respiratory tract. The root is the superior attachment point of the nose located between the eyes. It serves as the structural foundation for the external nose. The bridge forms the bony upper part of the nose, providing structural support and shape. It is primarily formed by the nasal bones. The dorsum nasi is the length of the nose, extending from the root to the apex, creating the central ridge of the nose. The nares, or nostrils, are the external openings of the nasal cavity, allowing for the intake of air and the passage of respiratory and olfactory substances. Cartilage within the nose provides structure while allowing flexibility. The lateral, alar, and septal cartilages form the framework of the nasal tip and support the nares. The nasal conchae are bony projections within the nasal cavity that increase the surface area, helping to warm, humidify, and filter the incoming air. In addition to the nasal cavity, the respiratory system includes a set of air-filled cavities known as the paranasal sinuses. These sinuses are located within the bones of the skull and play several supportive roles in respiratory function. By producing mucus, the sinuses help to trap particles and moisten the air entering the respiratory tract. Additionally, they lighten the weight of the skull and contribute to the resonance of our voice. Each sinus has a unique location and function, which we'll review in brief. The frontal sinuses are located in the frontal bone, just above the eyebrows. The maxillary sinuses are the largest of the paranasal sinuses and are located in the maxillary bones on either side of the nose. The sphenoidal sinuses are located within the sphenoid bone, deep in the skull behind the nasal cavity. The ethmoidal sinuses consist of multiple small air cells within the ethmoid bone, located between the nose and eyes. The pharynx, commonly referred to as the throat, serves as a shared passageway for air, foods, and liquids, connecting the nasal and oral cavities to the larynx and esophagus. The pharynx is divided into three distinct regions, each with its own specific functions. The nasopharynx is the uppermost part of the pharynx, located posteriorly to the nasal cavity. It serves solely as an air passage and is lined with ciliated epithelium to help filter and trap airborne particles. The nasopharynx also contains the pharyngeal tonsils, which are part of the immune system and help defend against pathogens entering through the nose. The oropharynx is the middle portion of the pharynx, located posterior to the oral cavity. This segment serves as a pathway for both air and ingested materials, making it part of the respiratory and digestive systems. The oropharynx is lined with a more protective type of epithelium to handle the abrasion from food and liquids passing through it. The laryngopharynx is the lowest portion of the pharynx, connecting to the larynx anteriorly and the esophagus posteriorly. This area directs food and fluids towards the esophagus while allowing air to pass into the larynx. The laryngopharynx ensures that food does not enter into the respiratory tract by aiding in the closure of the larynx during swallowing. Let's take a look at the larynx in a bit more detail. The larynx is composed of several cartilage structures that provide both support and flexibility. The thyroid cartilage is the largest cartilage of the larynx and forms the prominent anterior projection known as the Adam's apple. It serves as a protective shield for the vocal cords and other internal structures within the larynx. The epiglottis is a leaf-shaped flap of cartilage located at the entrance of the larynx. Its primary function is to prevent food and liquid from entering the airway during swallowing. When we swallow, the epiglottis folds down to cover the glottis, directing food and fluids towards the esophagus instead. The cricoid cartilage is the only complete ring of cartilage in the larynx and is situated below the thyroid cartilage. It provides structural support and connects the larynx to the trachea, helping maintain an open airway for respiration. The arytenoid cartilages are paired, pyramid-shaped cartilages that play a key role in vocal cord movement. They allow for the opening and closing of the vocal cords, essential for producing sound as well as protecting the airway during swallowing. Now that we've examined the larynx, let's look at the glottic opening specifically. The glottis refers to the vocal apparatus, which includes the vocal cords and the opening between them. It acts as a valve that can open widely for breathing or close tightly to protect the airway, especially during swallowing. By adjusting the tension and position of the vocal cords, the glottis plays a key role in phonation, as well as in regulating airflow into the lower respiratory tract. The true vocal cords, also known as the vocal folds, are elastic bands of tissue within the glottis that vibrate to produce sound when air passes through them. The pitch and volume of the sound are determined by the tension and position of these cords, which are controlled by the laryngeal muscles. The vestibular folds, or false vocal cords, are located above the true vocal cords. They do not contribute to sound production, but help close the larynx when swallowing, providing an additional layer of airway protection. The cuneiform and corniculate cartilages are small cartilaginous structures associated with the glottis. They provide support and help stabilize the laryngeal structures. They contribute to the flexibility and control required for both phonation and airway protection. Inferior to the glottis lies the trachea, which is a tubular structure that serves as the primary airway, conducting air between the larynx and the bronchi. Approximately 4 to 5 inches in length and about an inch in diameter, the trachea is lined with ciliated epithelium and mucus-producing cells, which work to filter and trap particles from inhaled air. The trachea's structure is specialized to maintain an open airway while allowing some flexibility for head and neck movements. C-shaped rings of cartilage support the trachea, providing rigidity to prevent collapse while also allowing flexibility. These incomplete rings face posteriorly, with the open part of the C positioned toward the esophagus, allowing the trachea to expand slightly as we inhale, while also accommodating the esophagus when swallowing large boluses of food. The trachealis muscle spans the open posterior side of the C-shaped cartilages. This smooth muscle can contract or relax to alter the diameter of the trachea, controlling airflow. During coughing, the trachealis muscle contracts to narrow the trachea, increasing airflow speed to expel irritants more effectively. The carina is the point where the trachea bifurcates, or splits into the primary bronchi, which lead into each lung. Located at the level of the fifth thoracic vertebra, the carina is highly sensitive and triggers a strong cough reflex if irritated. This is a protective mechanism to prevent foreign particles from entering the lower respiratory tract. The mucociliary escalator is an important feature of the trachea's lining. Goblet cells produce mucus that trap particles and pathogens, while the cilia move this mucus layer up toward the pharynx, where it can be swallowed or expelled. This escalator-like system is important for keeping the lower respiratory tract clean and free of obstruction. The lining of the respiratory tract is composed of different types of epithelial tissues and specialized cells depending on the region. One of the most important specialized cells found throughout the respiratory tract are goblet cells. Goblet cells are specialized epithelial cells within the respiratory tract that play a major role in airway protection. Let's break down their main functions and associated structures. Goblet cells are responsible for the continuous production of mucus, a thick and sticky secretion that lines the respiratory tract. This mucus traps particulates and pathogens, serving as the first line of defense by preventing foreign materials from reaching sensitive areas within the lungs. Surrounding the goblet cells are cilia, small hair-like projections on the surface of the respiratory epithelium. These cilia move in a coordinated fashion to propel mucus upward toward the pharynx, where it can be swallowed or expelled. This ciliary action is the bronchi are the major air passages that branch from the trachea and lead into each lung. Their primary role is to conduct air to and from the lungs, progressively branching into smaller and smaller passages to distribute air throughout the lung tissue. The primary bronchi are the first branches off of the trachea, with one bronchus directed toward each lung. The right primary bronchus is wider, shorter, and more vertical than the left, making it more susceptible to foreign object entry. Each primary bronchus supplies air directly to its respective lung. The secondary bronchi, also called the lobular bronchi, branch from each primary bronchus to serve the individual lobes of each lung. The right lung has three secondary bronchi for its three lobes, while the left lung has two. The tertiary bronchi, or segmental bronchi, branch from the secondary bronchi and supply air to the bronchopulmonary segments. Each segment can function somewhat independently, which is useful clinically as it allows for targeted interventions or resections without affecting the entire lung. The tertiary bronchi further divide up into the bronchioles. The bronchioles are smaller branches that lack cartilage and are primarily made up of smooth muscle. These smaller passages can constrict or dilate to regulate airflow into the alveoli, a process controlled by the autonomic nervous system. The terminal bronchioles are the last portions of the conducting zone where air is filtered, warmed, and humidified. Beyond the terminal bronchioles lies the respiratory zone where gas exchange begins. The alveoli are located at the ends of the smallest bronchioles. They are the primary sites for gas exchange, with thin walls that allow oxygen and carbon dioxide to diffuse between the air and blood.